Hello, teacher. Welcome to our project. My name is Önder. Before we train the image, we set 30-30 and test size 20, train size 70. We use batch size because if we didn't use batch size, values would be very low. Um, and go to load data function. Load data draws pictures of the data. This function here we have resized images we did using NumPy.
And here we have the get model. And inside the get model, we initialize our model using a sequential method. And inside that method, it allows us to use many different methods such as conv 2D, max pooling 2D, dense, and etc. And below, we have the optimizer. We used ADAM, but as we mentioned in the report, that ADAM showing poor performances, so switch to SGD, which performs better. And below that, we compile our model, and at last, it's all we call the main. The results of the tropic.py, as you can see, it's a little bit, it decreased a little bit due to the optimizer and the testing and validation and training parameters.
In this part, we took the pictures in the path and resize them. Then we create an array and a building model. Many have model this here, and we used callbacks to create a tensor board. We compile the model and we use ADAM. We have saved in my model data.
And below that, we have the plots. We are using the matplotlib library we imported above, and here we are using the methods, common methods of it, and we want to print the accuracy and val accuracy as well as with loss and val loss. And below that, we just save our labels and images inside the test CSV. As you see, we have the accuracy stabilized at 95%, and we have the val loss at 0.3% and val accuracy 99%, and we have the plot, as you see. And this one is the loss plot. In your recognize.py file, we are using the takeinter library in order to initialize a GUI. And here we have a classes array, and inside this array is actually a dictionary, and its purpose is to serve as a kind of a model. And going below, we're initializing our GUI with the help of the take method, and we are setting the size to 800 to 600, and below that we're just setting its title and configuration like background and stuff like that. And below that we have a classify method, and in this method we are adjusting the data, and in this case the data is the images. We are resizing it to 30-30 because that size is the actual size that we trained in the train process.
Show classify button function, we create button this function, and we made the designs events with the conversion method, and we made its position with the place method, and we called the button and resized the pictures, and this project done. This is a GUI section. Click upload an image button and upload image to system. Go to this document and click this traffic sign and predict the result. This image turn right ahead result very correctly.
So after the compilation of the Learn SciPy, we have created log files and we can access them through TensorBoard. You see we have our address, and open up your desired browser. It doesn't really matter. And here you see, with the help of the TensorBoard, we can be able to see the plots, accuracy, and loss. The graphs. This is irrelevant though. And a time series of both accuracy and loss.